Okay, good evening, everyone, and also good morning to friends from other region. So welcome back to this RoboCup at Home Education Online Challenge 2021. So I'm Jeffrey. Together with me is engineers from Jupiter Robot. Today we will bring you this open platform online classroom. Okay, and today will be today is the fifth class, which is also the last class for this online classroom series, and we will discuss about robot system integration. Okay, so for the first half, we will talk about the application development. So I guess this is the question that very popular. Many teams actually ask me like, so how to actually put all those things that you have learned in the previous class together. So I believe today the content will be very important, especially you want to build a complete robot for the competition. So hopefully like you can follow us and we will discuss about this topic so that you can develop your robot after this. Oops, sorry. Okay, so as usual, we divided our class into two sections. So for the part A, we will discuss about the application development, which is mainly we will combine everything that you have learned in the previous classes. For example, like you learn about speech interaction, you learn about visual perception and also navigation. So your robot can do all this function like separately. So now you want to combine them together so that you have a fully autonomous or a fully automatic robot that you can give, for example, like you can give one command and the robot can do everything by its own after that, right? So fully automatic. So that will be the content that we'll discuss for the first half of today's class. Then for the second half, I will also spend some time to explain to you about the competition. So maybe like we assume many of you are beginner or maybe don't have any experience about the competition. So we will discuss and also we will share you some experience about the competition. So how the competition look like, what are the requirements, and how to join and so on. So especially on the technical aspect, like maybe you read the rules, but you can't really visualize. So we will show you some videos, we will do some explanation for you to understand the process of the competition so that you can design and also prepare for competition better after this, right? Okay, and as usual, so the few link down there is for you to get the materials in front of you, for example, like the slides, or you want the video recording of the previous classes, you can go to the second link. You can find all the materials that you need over there, including our assignment and so on. Then if you want to interact with us, okay, so here is our class group, but also feel free to sign up the entry application that I just said just now before the class regarding the entry application for the teams. Okay, so if you sign up for that entry application, then we can keep in touch more, and anything you can just write to us from there. Okay, so for more interaction after this. Okay, so before I start the class, final reminder for privacy. So in the whole session, please turn off your microphone and also your video cam or your webcam, okay? Because we are going to publish this video after this on our website and many other places to share the content to the public. So make sure you don't turn on your microphone or your video camera. We will have time for interaction after the class where we will stop the recording and we can discuss more after that. Okay, so thanks for your cooperation and let's start the class. Okay, so for today, we will discuss about the robot system integration. And over here, the system is the robot system, and then it comprises of hardware, both hardware and software. But for hardware, we won't talk a lot about, like, for example, the mechanical integrations and so on. It's because like that actually depends a lot on what kind of design and what kind of tasks you want to do. Okay, so we won't talk a lot about the mechanical integration in terms of like the mechanical structure and so on. But over here, we will briefly tell you like what are the components that you need and how you want to put them together. Okay, So I'll just tell you like, okay, you need to put your microphone, you need to put your webcam and so on in certain position, but how to fix them together, that actually heavily depends on your robot design corresponding to your task that you want to do. Okay, so that one, I will leave it to you. So over here will be very basic, just explain what are the hardware component that you need. So over here, I list now. So you need a laptop computer, basically have everything that you need, okay? Your laptop computer will have the microphone and speaker built in, which is most of the cases. Then you will have your webcam also most of the cases built in. Then for navigation and ARM module, if you would like to include those things, okay, you can use the simulation model, which is available in our VirtualBox, or you can also install the software by yourself, as we discussed in our previous class. So maybe the ARM module is optional over here, which we don't really explain before in this class series, but you can find ARM-related classes or information on our website as well. So some of our previous classes actually explain a little bit about the ARM. Okay, but we will show you some integration with the ARM module as well, because like the software and everything actually already available in your VirtualBox. So it's how you want to run it and so on. Even the sample code already there. Okay, so later on I'll explain this in a little bit more detail. Okay, then for the software as usual, the Ubuntu and ROS, and also the related component software, which is everything already inside your VirtualBox. Okay, so basically that is what you need. But if you have some hardware that you would like to address or you would like to know more, feel free to contact us and tell us what hardware that you're using, and we can discuss how you can use them in your competition after this. Okay, so for today's content, we will divide into these two parts. So the first part is about application development. And for the application development, I'll focus on the summary of previous classes. Okay, so this is to rehab and also for you to revise what we have learned previously, but I will just touch on the main point. Okay, so the important thing, so that you know what are the things that you have really learned, just in case like some of you might miss some of the classes. So I will give an overall so that you know like the whole online class series, what we have discussed previously, so that you have the overview in order to discuss our main topic today, which is the system integration. Okay, so once you know all the component, so how we can put them together, that will be the main discussion for today. And for that discussion, I will use two examples. So the first one is about the people tracking the follow me. So the follow me is already like, it's a default application sample in the Turtlebot, but I will explain more from there, like how you want to integrate with other parts, and eventually you can put in your robot application. So a complete robot application that I will use it as example today will be the PartyBot. Okay, so you can find this example actually already like downloaded in your software repository. It's already in your VirtualBox when you install, but you can also get all this software from our GitHub repository as well. Okay, so I will tell you more after this. Then for the second half, we will focus on the competition, which is I will explain a little bit about the rules, the at-home rules, the at-home education rules, and what are the content. Okay, so like we know the rules, we know a few tasks, but what are the content for the tasks and what you should take notice when you want to develop. And also I will show you some video for some example that my team previously developed for the particular task. Okay, right. And then for the open challenge and the COVID issue, okay, that one is the task for this year online challenge 2021, which is I will also explain to you briefly like how we expect those tasks to be addressed in the competition. Okay, so that is the overview for today's class. Okay, so first thing, I would like to give a summary about what we have learned from the first week until today, and also the missing one is the robot arm. Okay, so we don't have enough time to actually prepare for another class for robot arm, but it actually make a lot different if let's say you want some application that require manipulation. Okay, yes, I saw. Okay, do you want to ask question or any other thing? So for the audience that you have raised your hand. Okay, we will do the interaction after the class. So maybe you want to keep your question until the end of the class so that we can have some interaction. Or if you have anything urgent, I will suggest that please write. Sorry, please write in. I'm sorry. Okay, I'm not supposed to scroll this. So if you have anything urgent that you would like to contact us, I will prefer you to like maybe you can drop me an email, okay, so that I can check. Okay, unless you can write in the message box, then I can also read from your message box. Okay, right. Okay, so for the ARM, okay, so you can find some other classes in our courses library, maybe that you can find some reference, but today I'll briefly tell you like the example that we have so that you can try it out on your own, okay, for the ARM. Right, so for the summary of previous classes, we have 4 classes before this. So the first one, we start from the robot development system. So the first class, we discuss about how you want to build out your development system. Okay, which is you want to start build your robot. So what are the components you need, hardware and also software. And over here, we actually tell you something very simple and very easy to use, which is like you just need your laptop, and then you just need to install the VirtualBox and mount the image that provided by Jupyter Robot. And basically you have the whole environment. And with that environment, we also show you the ROS basic, okay, which is okay, I should turn the next slide. Okay, which is like this, which is you learn how to actually start to write some program. Okay, but before you write something, like you need to know like the architecture, for example, like how the overall architecture of ROS, the concept of node, the concept of messaging between the nodes, the topic, and so on. Okay, so the ROS master, the ROS call. So how you want to like execute, for example, you need to execute the ROS call, then you execute the node, or you can run everything by using the launch file and so on. So these are all the things that we learn in the ROS basic. And inside in that particular class, the most important thing that you need to really familiar with is the publisher and subscriber. Okay, the publisher and subscriber, which is the function in the node that you use it to communicate between the nodes. Okay, right. So you can write one publisher in one node, and then you can write another subscriber in another node, and then they can actually communicate or talk to each other by using a topic. So the publisher node will publish the message into the topic that you define. Then another node will subscribe to the same topic in order to get the data. So that is how you connect them together. And with this architecture, basically you can pass the message from one node to another node. And eventually you try to imagine like when you have this thing in multiple, so your whole program will talk to each other. You can have a lot of parameters passing around. And that is how the building block that you use to build up your whole program for your robots. Okay, so you have a lot of different nodes that all these nodes will actually do a certain function or a certain task. For example, okay, so just a reminder, please turn off your microphone, okay, especially for newcomer. Okay, right. Okay, so for this publisher and subscriber, once you know how to use them, you can actually apply in many cases. because after this class, we actually discuss a lot of robot functionality, for example, like speech interaction, for example, like visual and so on, and how you want all these functions to work with each other. Basically, you just need to use this publisher and subscriber. Okay, I will like you to turn off your microphone and webcam, please. Okay, for particular guests, please turn off your microphone and also your webcam so that we can run the class smoothly. Thank you. Okay, so for this robot development system class, we learn how to do this publisher and subscriber. So just in case that you are still not very clear about this concept, maybe after this, I will show you some example how we actually put certain function and combine with certain function together to come up with a particular example or particular application that we will discuss after this. Okay, but no matter what, this is a very important basic that I hope all of you can understand or try to do some exercise in order to get familiar with this concept. Okay, right. So if any of you have any question, we will do the interaction after the class. Okay, maybe we will do it like, let's say, like we have many inquiries, so we will do it maybe at the halftime. Okay, so after the first hour, we will open up for you to have some Q&A if, let's say, you have any urgent matter to discuss. Okay, so now just let us run through the slide first. Okay, so this is for the robot development system. Then we start the first function, which is the speech interaction. And although speech seems like one function, but inside there is actually divided into several things. Okay, so for example, like we only talk about two parts, which is the first one is about robot speech synthesis. So it's to show, is to make your robot able to say something. Okay, so you can like program a particular sentence for your robot to say it out from the text to speech. So that is the speech synthesis. And with this, your robot able to talk like normal human being. Okay, so it can sound like you normal human being, but the content is whatever that you written in the program. Then the second part for speech interaction is we have this speech recognition, which is the reverse of speech synthesis, which is you provide the audio file or you speak to the robot directly, naturally in a human natural voices. Then the robot will try to, not to say understand, but to detect, okay, to detect what have you said in the particular sentence. So what the robot or what the machine does is like the machine will translate from your audio back to the text. So the system eventually will get the text, the transcript of whatever you say, but the accuracy and so on, we already discussed like how you want to do the, how you want to improve the accuracy of the recognition. And you also need to aware that there will be a lot of noises, you will have a lot of false recognition and so on. And all this, you need to have many strategy in order for you to build a very good or reliable speech recognition system in order for your robot able to listen precisely what the human want to say, regardless whether we have very noisy environment and so on, because noisy environment is the norm. It's the normal that is going to happen. So from there, we discuss also about the microphone, discuss about the strategy to like ask back the based on your confidence level, you can ask the user to reconfirm the content and so on. So these are all inside the speech synthesis and also recognition. But as this diagram that I show you actually show the whole flow of the speech interaction in a human robot interaction. So you can see we only touches like two parts. Okay, so the speech recognition, which is from the input, like okay, a human say something, then from the mic you pick up So the speech recognition try to get the content. Okay. Another information that's important for a robot to know, but we don't actually cover in this class, is the sound detection and localization. Okay, so what is this and why it is required in service robot is the example is like if you have a microphone array, so similar like human, we have like both sides, we have the ear from both sides. So the sound from certain direction, we actually can try to recognize the direction based on the different timing the audio, the sound actually reach our ear. So this difference of timing actually can also pick up if we have a microphone array. Microphone array means we have multiple microphone put in a certain direction so that we can calculate the difference in terms of time they receive the audio. So with this function, the robot actually can try to estimate the direction. Okay, and why this direction is very important is very similar like human, because when we interact with other people, we actually need to like, okay, for social etiquette, we need to like speak face to face to that person, okay, for better manner and so on. So for robot, actually human might have the same assumption when talking to robot as well. So human might also prefer if, let's say, the robot can face to that particular human when they are talking to each other. So for that purpose, this sound detection will give extra information for the robot to actually turn to that person and talk face to face. So that is something important for us to consider. But this one requires additional hardware and also additional computing in your program. So that it depends on how you design your robot and whether you can do this, or else your robot will be like quite like statics, and that will make human feel very robotics attitude when they're talking to each other. Okay, but well, that is depends on your design, also the requirement. Okay, right. So for then after that you have the speech understanding and the dialogue manager. This one also we didn't discuss much, but later on in the party board example, I will show you some very basic speech understanding. Okay, basically it's not really speech understanding, but some very simple dialogue logic for you to actually do a Q&A robot. So which means like the robot can try to pick up certain keywords so that we can estimate what kind of question your user is asking so that you can give the appropriate or correct answer. Okay, so that is a very, very basic form of dialogue manager. In fact, we have this natural language processing, which is a big field for this speech understanding or natural language understanding research and also development. So it depends on how much understanding the robot needs in order to carry out the task, the duty. But for a normal Q&A, for like, you know, those automated answering machine and so on, yeah, we can use some strategy that I can show you some example after this for you to do the development. Right. So that is basically for the speech understanding and dialogue manager. And then you have the speech synthesis, which is you give the answer and that's complete the loop for the speech interaction. Okay, but of course over here, there are many things we didn't cover, but I hope like you have the overall view on how we want to design the robot speech interaction. Okay, so that is for the class number 2. Then we have the class number 3, which is we talk about robot visual perception. Okay, so visual perception is where we try to use sensor to obtain information from the robot surrounding. And what kind of information is RGBD, which is the color information, and also the distant information, the depth. Okay, the RGBD. And then we actually can have that information in 3D. So as you can see, like in this RVs, okay, so in RVs, we actually visualize the data that we obtain from our GBD sensor. So you get something like this. So you can see like this color actually represent different distance, okay, different distance, which all this color actually made up by a big group of data point, okay, and all this point we call it the point cloud. So if let's say you put in if you just look at the 2D color information, so you get something like this, which is over here you can see like there's a bottle here, then we have the chair, and then behind there got a cabinet and so on. So it's very similar. Like over here you can see like the bottle is over here, and then we have the chair, and then behind there is the cabinet and so on. Okay, so you can see the depth, the distance information, and also the distance and also the color. This is the color and the distance information. And from here, we do some processing. Okay, so for this visual perception class, not just getting the data, but also we have half of the class that we talk about how we can use the information to understand certain how we can use the data to understand certain information about the surrounding. So for example, I show you like we use the OpenCV library, and we can do the face recognition, we can do the face detection, people detection, and also inside the Open CV application, we actually have in the library, we actually have a lot more like age detection, the features tracking, and so on. So you can optical flow and so on. So you can have a lot of all these things. We have a lot of library that is open on the internet that you can use it for your image processing. So from there, you can grab the result from the processing in order for you for your robot to do something else. Okay, so for example, like when you want to detect faces, so you use the face detection program, then the program will give you, like for example, how many faces and where are the location of the faces, so you can use directly this information for your application development. So for example, like if you are designing a receptionist robot, so you can like new guests actually come into picture or come in front of the counter, so you can actually give the robot can give some greetings and then ask some question regarding like what kind of service like the user might want to do. For example, like want to check in, want to ask for the information and so on. Then the robot can provide the service, and also the robot can try to also learn the face by using the face recognition, like by asking the name and try to record down, take a few photos, then you can record down, so that the next time when the same guest come into the picture or approach the counter, the robot can actually give more personalized services. For example, like can address that guest name, and also for example, like you already know like what the guest is doing in the hotel, so you can provide a different set of more personalized service for this particular guest. So for example, like okay, then the guest might say, I need something in my room, so you already know like which room the guests stay in and so on. So you will make the robot sounds more intelligent when dealing with the guest that the robot already know. Okay, so these are all the things that we did in our third class, which is in this robot perception, visual perception. So you can use all these things for your application development after this. Okay. Then we talk about the navigation. So the navigation is to make your robot able to move around, but before you want the robot to be able to move around, so the robot needs to build a map. Okay, so the first half of the fourth class, we actually discussed like how to build the map using the sensors available on the robot. So we use you can use the laser sensor, which is give you a nice, clean, accurate 2D plane laser scan, or you can also use the RGBD sensor, which is it actually mimic the same laser scan, but maybe the accuracy is a bit less compared to the laser scan, laser sensor, laser radar, okay, the LiDAR, but both, yeah, can do the job for the scanning of the environment to give you the map. So we also discussed like quite lengthy about what is the concept of SLAM, what is the concept of localization, odometry, and so on, so that you understand like how the map can be developed based on the robot movement and also the scanning of the sensor. Right. So that was the first half. Then for the second half, you try to use the map. Yeah. Right. Just a reminder, please turn off your microphone and also your webcam, please. Thank you for your cooperation. All right. Please turn off your microphone and also your camera. Thank you. Okay, so for the second half in the robot navigation class, we use the map and we want the robot to move from point A to point B. And over there, the important concept is the localization and also a tools called AMCL, okay, Monte Carlo localization. So that is the tools that we use. But also during that class or that time, we also explained about the path planning, right? So because you want to know how, for example, like in this picture, so you can see like there's a red line in front of the robot. So that line represents the path calculated based on the information from the map and also the information of the waypoint that you assign to the robot. So based on the starting position, based on the goal point, and based on the map, like the distribution of the object, obstacles, and so on. So we have certain algorithm to do the path planning. So to plan a path from the starting position until the goal. So we discussed about that we use the A star, which is we try to find the shortest path and so on. Okay, so once you have this path, the robot will try to like move one step at a time and also try to do the object detection, so that if any dynamics obstacle actually move past the robot throughout, like in any particular point on the course, then the robot will stop and try to avoid the moving object, and it will replan the path planning so that it can have a new route, avoiding the new obstacle and reach the final destination. So that is basically the continuous processing for the path planning and also for the localization. Okay, so with that you can do the autonomous navigation for the robots. Right, so basically with all those elements, we can actually put them together to do something more meaningful, as in like to solve a certain task, right? Okay, so once we have all those things, so what we do is we try to put them together. Okay, so just now was more discussion about the software. So the next thing I would like to say is like, okay, although we are not going to say a lot about the mechanical design or mechanical integration, but just want to tell you, like in open platform, which is OP, you are free to design your own robot. And that is actually part of the objective of the competition as well, because we also hope you can come up with some interesting and also some useful mechanical design for particular functionality of the robots. So for example, over here, what we did a lot previously in this education league is we try to extend from the Turtlebot 2 to build service robot functionality. So you can see like from Turtlebot 2, which is just a moving base, and then with some platform to put the sensor in between, and also we can put some additional things on top. For example, like you can also put the laptop on top or down there, right? So those are the structure, the very primitive basic structure of Turtlebot in the very initial state. Okay, Then after that, you can see like as time go on, we try to put an arm, we try to put a second visual sensor on top in order to do the perception or do the interaction with the human. And also we try to couple the visual perception, the top one, with the arm so that we can have a visual based object manipulation, okay, so that you can have a closed loop feedback manipulation, planning, and so on, right? So you can see over the time, we try to extend the Turtlebot 2 mechanically so that we can achieve the service robot application. For example, like when we want to grab something from top, then we need to build the arm and also a secondary visual perception on top, okay? And also we have other case that we need to grab something from the floor. Then we might put the arm below, not instead of like on the top plate, we do it on the last, like the bottom plate and so on, right? So you can see we actually change the design, the mechanical design, the combination in order to extend the robot functionality for a particular task. So it depends heavily on what kind of task, whether you want to grab something on the table, from the bookshelf, from a top shelf, or from the floor, then your arm might be different, might place differently on the robots. Then also together with that, your RGBD sensor, where you should put your RGB sensor so that you can have the feedback for your arm, and also your microphone. So where we should put your microphone. For example, like in this case, you can see like down there, we put the microphone on top, like that is the tallest you can go. And also like over here, we might use, yes, again, I would like to remind you to turn off your microphone and also your webcam. Thank you. Right. And also some cases where we want to have a more natural human-robot interaction in voice and in speech interaction, we also put the microphone, for example, like we use the microphone over here, right? Which is like we put on top so that it can have the same level with the human for better reception of the voice and so on. So these are all the things that you have to consider when you design the mechanical structure of the robot, when you have certain requirement for your module. For example, like your speech module, you need the microphone to be near to the user and so on. So you will think about all these things, okay? So this one you extend from Turtlebot 2 and eventually you can come up with different design. So in this competition, we actually look on this kind of design and hope you can optimize certain design for certain functionality as well. Okay, so feel free to design your robot, but make sure that you check our rulebooks to know certain do's and don'ts, okay, for the robot design. Okay, so over the year we actually have different configuration for different tasks. As you know, in RoboCup we have different many different tasks, and for different kind of tasks it might have different requirement in terms of the speed, the speech interaction, in terms of the visual perception and so on. Sometimes you want the camera to be in front, sometimes you want the camera to be on the top, sometimes you even need the camera behind so that you can see something behind and so on. We actually have one time that we need to do the follower reversely, okay? We need to do the follower and also the scanning of the map, so we have the visual perception in two different directions and so on, right? So these are all the things that you need to consider when you look at the task and you design based on that for a mechanical design. Okay, but somehow we come up with quite a standard design eventually for a more general development. So just in case that you might just want a standard way or a standard robot that you can follow so that you can have a base that you want to do like this, a very like basic service robot development. So this is one of the prototype that we developed. So the prototype look like this, that we use it for our workshops and also our teaching and learning materials. Okay, so this is the platform or the design that look like this. So, and inside there we have this 5 element, which is the first one is the speech interaction and GUI, which is this part. Okay, the A, which is this part. So you have the microphone and you have a touch screen over there. So this one is for your human robot interaction. Okay, and for your speech interaction and so on. Then you have the second part, which is the visual perception, object recognition, or human recognition, and so on. So we have an RGBD sensor on the top. Okay, so this one is for the robot to interact with the user, particularly to the user, or it can also be used to couple with the manipulation of the arm in front. Okay. Right. Okay, so we have the second part, which is a robot vision. So we do the design like this, so that from this height and also this position, this sensor can actually see the area in front of the arm, so that we can do the planning for the manipulator. Then, of course, we have the mobile platform, which is the part C inside this picture. So we use the Kabuki, which is the base for the Turtlebot 2 as well. But for your case, you can choose any kind of mobile platform you like, okay, as long as you know how to control and you can interface with ROS easily. But over here, we use the Kabuki, which is we feel like it's quite easier for us to work with, because we already have all the programming resources from Turtlebot 2, and also the Kabuki teams also try to update their code according to the development of ROS. So this makes us very easy to work with this platform. But similarly, you have many choices. For example, you can choose like Roomba, and Roomba have the developer edition, which is a create. You can use that as well, or you can use any other floor cleaning robot that you can hack or you can like modify, as long as you are comfortable to work with. And particularly important is like, if let's say it is ROS ready, then it's easier for you to integrate with the rest of the part. Okay, so this one. But of course, the mobile platform is not just the moving platform by itself, but it also need a feedback for the sensor feedback. So which is over here, we have another RGBD sensor located below there, but you can replace this with a laser sensor. Okay, a laser scan, which is the LiDAR sensor, which it will work in a similar fashion by using the standard ROS navigation package. Inside that, there got many ways that to do the SLAM. For example, you can use the G mapping, or you can use the Google way to do the cartography and to do the SLAMs and so on. There are many ways to do that. Okay, so you can use this to provide the movement for robots. Okay, and it's important over here is like the moving base is always the most basic thing that you first want to think of, because if you need a very big or very heavy or very precise project, then you might need quite a compatible, I mean, in terms of functionality, it got the accuracy and also the performance that you require. For example, if you need this robot to carry very heavy load or very precise movement, then you might want to consider a better mobile platform. But for this at-home education competition, yeah, something like the Roomba or something like the Kabuki is good enough for your application. Okay. Then lastly, is about the robot intelligence, which is you need your computing unit. So over here, we recommend you to put in a laptop. Okay, that is the easiest way to work on. But for example, the design from Jupiter, they are using an Intel NUC, which is a small computer box by Intel, and that works perfectly fine. But you might need a display. So, but we already have a display up here, so it actually gives you sufficient functionality, even just with a PC box, as compared to a full functional laptop. Because like full functional laptop actually in this case is quite troublesome, because like you need to open it up, you need to put it somewhere, and the screen usually you don't use it. Okay, so it's quite a waste. So our design, we actually changed it to use a PC box, which is an Intel NUC. It works much better, but you can of course use many other computing unit. For example, if you want to use, for example, like the Jackson NVIDIA board or so on, or other thing. And even some people, they try to use Raspberry Pi and so on. It might work, okay? But Raspberry Pi, as you compare with Intel x86 based computing unit or computer board, is of course in terms of the performance and also the computing power, yeah, is very different over there. So you might want to take note. And some people actually ask me, like, do they need like a GPU? Of course, if you want to do a lot of deep learning stuff, then a GPU board can give you more power to do that. Okay, but we try to reduce too heavy duty computing on board, is because like our robot intelligence system also designed in order for us to use a lot of cloud computing. So we use a lot of cloud API or cloud services. For example, like for our speech, we can use a lot of Google speech. We can use other things like Baidu and other stuff in order to do the heavy lifting. Okay, because like if you want to do your speech recognition on board, then you need quite a very heavy computing unit in order to do the calculation and so on. And also you need a big database and so on. So in that case, maybe a cloud service will be more appropriate. But of course, in the competition, you also want to be aware that you might don't have the luxury to connect to the internet. Okay, so that's all the things that you need to consider. Okay, so far we have this prototype, and we actually open this design and let you like use this design for your development as well. So feel free to design, and all the parts we actually have already have the sample code that we put on our repository, that feel free to use it. And also in our class, we actually explain to you how to use all those things. Okay, so yeah, so this is a design that we encourage you to attempt for your service robot development. Okay. Then, okay, I would like to over here also as our sponsor, Jupyter Robot. So what they did was they actually improved this prototype and make it into live product. Okay, so but it is more like a kit. So it's a robot kit that have all the things that we mentioned before, that put them together, and they already work on the software integration to make sure everything works as a whole. And with that, you have to complete this Jupyter Robot, which is, how would I do off the sound? Okay, so I can show you some video that you can use them for your development easily. Okay, so this one come already like in the whole set, so you need to build everything by home. But of course, like for open platform teams, you are advised, also you are encouraged to develop your own robot and so on. But if you want to have a head start, so this is one of the solutions that available, that you can have a look, and also you can refer. And also, like if you need their services, yes, Jupyter Robot is with us in this in our activities. Okay, so to build the map, and then use the map for the navigation, and not just that, like for example, like all the visual perception example, they already like verify and make sure it's run smoothly on the hardware that is come together with, yeah, speech recognition, speech synthesis, and so on. Okay, right. So this is for the Jupyter Robot, and also in our simulation, navigation class, we also show you like with the Jupyter Robot design, they actually prepare the simulation world, which can give you the development environment both in real world and also the simulated world. Okay. And you can do the same thing actually, like you can build your robot, build the model, and then do everything in Gazebo as well. So you build like the physical environment, then you measure everything, then you build the same thing in your Gazebo, then you can achieve something like what we shown in our class, which is you can do the navigation in whether, okay, for example, you can build a map in Gazebo, and then you can use the same map in the real world. Or you can do the way around, like you can build the map on the real world and use the map for your simulated world. as long as you have all the measurement correct, you have the scale correct 1-to-1, then it is proven quite accurate that we already show you in the class that we can obtain a very acceptable result from between real world and also like simulated world for the navigation development. So if let's say your labs or your department focus on mobile robot design or mobile robot development, yeah, this is something that encourage you to develop so that you can have very rapid development in the simulation world, or even you can speed up your learning because like whatever that you can obtain from the simulated world, actually it represents quite closely with your real world. Okay, so that is something that you can try. Right, and one more thing before I start to talk about the software of integration. Before I jump into that topic, which is the main part for the first half, I would like to once again tell you that we actually have another set of okay, I don't know why this is not. Let me try again. Okay, maybe it's loading. Yeah, okay, it's loading good. So we actually have another set of source code and also example that we can build a service robot with all the topics that I mentioned before, like speech recognition, navigation, computer vision, and even computer vision with machine learning. We have this set of example, okay, that you can use MATLAB to do all these things. Okay, so together with, for example, like the Turtlebot platform that we have here, right? You can use the example, our example, that we work together with Meshwork to come up with a set of example that you can run on your robot to achieve all these tasks. And all you need is just ROS and also Meshwork for the software. Okay, so although this time we don't really run the class for Meshwork, but we have on 5th/10, actually now is in the process of arranging, we will organize an invited talk to invite engineers from Meshwork to show you how you can develop our service robot by using MATLAB and also Simulink, right? And all the tools developed by Meshwork, right? And so this was done by last year, that together with an engineer from Meshwork as well. So we have a set of source code openly available on GitHub, our GitHub repository, and also you can go to our video playlist to see a set of video to explain to you how to use MATLAB to develop all this function robot service robot functionality. For example, like how you want to make a robot speech recognition synthesis, how you want to do the navigation for robots based on the Turtlebot base, and also the computer vision based on the RGBD camera that we have, and so on. And also even manipulator. They actually have one sample manipulator that you can refer to, right? So if you're interested to use MATLAB or you work on MATLAB for your development, yeah, feel free to look at this set of code that will help you a lot in speed up your development for service robot. And also one final notice is like this time for at-home education teams, we are also encouraged to join the virtual robot manipulation challenge, which is parallel with our RoboCup event. And you can also use this development for your team submission for our at-home education online challenge 2021. Okay, so just in case, like if you're working on this robot manipulation, like using this one, you can use the same entry actually for your at-home education as well. So vice versa, you can work on your project here with MATLAB, or you can also use this robot manipulation content for your at-home education development online challenge as well. Okay, so we are as Meshwork setting. Okay, once again, I would like your cooperation to turn off your microphone and also your webcam, okay? Okay, so for the learning resources that over here we have is like the online classes that you currently are having. And then we have a community, which is on robot, like we host all our course materials. And okay, I hope you don't mute my mic. Right, okay. Then we have our source code at GitHub. Our video, you can go to our official YouTube channel, our channel over there for our video, like not just the class video, but also we have some robot video over there. And also like this will be the parts that I'm going to explain after this, which is we already use a lot in this example, but today I will explain to you about this apps part, okay, the application part, which is I will show you how you want to build an integrated example or integrated service robot example application. Okay, so last week, if I'm not mistaken, I already showed you this, which is the Turtlebot follower, right? So you can go to the ROS wiki to see the example explanation and so on. And in order for you to launch, if let's say you have a Turtlebot with you, you can use this. But in fact, you can do the same thing in your gazebo. The only thing is like you need to have something for the robot to follow, which is this is not easy to achieve unless you know how to do it. Okay, but just in case you have the Turtlebot with you, yeah, you can bring up and then you launch the node, and then you can use this RQT to play with the parameters which I explained, like the virtual box in front to get the node so that the robot can actually calculate or detect the object in front. Okay, right. So these are the things. Okay, but today's class, this is right. So I hope you don't mute me, just in case that you accidentally press mute. Okay, I hope you still can hear me. Right. For this follower tool, is how you want to integrate this follower program to your program. For example, like now, you are developing a new program for your service robot, okay? So for example, you are developing a receptionist robot or how to say, a robot for the restaurant, okay? Like to act like a waiter or waitress in a restaurant or so on. So for example, you are develop a new service robot application and you want to incorporate this follower program into your main program. So how you want to do that? Okay, so for example, the first thing is like you might want to make sure your sensor, you have the sensor for your follower, okay? And over here, we use the Astra sensor, but of course you can use any RGBD sensor as long as you can obtain the point cloud. So over here, we take the example like if we use all right, I have some. Okay, I'm not sure like if you can hear me, but apparently like my mic was mute by someone. Okay. I'm not sure, but the connection seems not so stable today. Okay, let me continue. So if let's say you want to include this follower in your program, so all you need is to include this follower control in your coding. Okay, so what is follower control? For the original Turtlebot program, they already have one what we call the service inside there. Okay, so it is using another protocol for communication, not the. Okay, I have a very funny thing, which is okay, I need to do something. All right, okay, so I hope now it's okay, right? Okay, I hope now it's stable. So let me come back to this follower. Okay, so for this follower, which is quite popular, that people would like to incorporate into their service robot application. So what you need to do is you can use this follower control that we provide in our repository as an example to incorporate into your coding so that you can turn on and off the follower code. So as long as you run the follower program and then you have this control with you, you can turn on and off. Okay, so you can just run the follower and then you turn off and your robot can do other things. But when you need the follower, then you just use your follower control to control it. Okay, so that is how you can use this follower control in order to incorporate this follower tool into your main program. Okay, but over here, I would like to show you like how this is done. Okay, before that. Okay, so let me look at the example. Right, so if you go to our I'll see, okay, this one, we might start from here. Okay, we can start from here. So once you have download or clone the program, you will have all these things in your Catkin workspace. Then inside here, you got this apps, okay, which is you can find two folders inside here. So one is the follower and one is the party bot, right? So for the follower, okay, you can see it's just a very simple, you just have a script, which is the follower controller. So this is the Python code that you need. Then we have the launch, which is to run this follower tool, okay? So if you look at this follower tool, okay, it have all these things, which is the same launch file as the original follower, okay? Except it already tuned for example, like what kind of sensors that you use and so on. So you only change this if you know how to do, and also these are all the parameters that you can predefine. For example, like how big, and so this one depends on your environment. For example, like you have a very narrow passage and so on, then you might want to change the value over here. Okay, but if let's say you are not going to change anything, you can use this as it is. Okay, so for this follower, so all you need is like refer to the script, which is this is where you need to see. Okay, so if you look over here, so this is the things that you need. Okay, which is very simple. It's like you just need to define what we call a service. So this is a different protocol for the node to communicate as compared to the publisher and subscriber. So if you have a publish subscribe, you can pass the message to each other, right? Okay, but for the follower, in order to do the communication, they are not using the publisher and subscriber, but instead they are using another protocol called service. So you can look for the ROS wiki for the explanation about the service. But if you're not really sure and not yet you want to know in detail, you can just use this example first. So all you need to do is like, yeah, you just need this part of code in your main program. So in order to control, and over here, I just separate out, and we are over here, we use the command by the keyboard. So you can actually replace this with your algorithm or your logic in your program. Okay, so for example, like if you want to stop, so instead of pressing C, okay, maybe when you have that particular, for example, like you do a speech recognition. So if you hear like follow me, then you turn on, or you hear like stop here, then you turn off. Okay, so you can use this part of code to combine with how you want to give command for this follower, right? So over here later you can see like I actually use this part of code in the party board in order to incorporate the follower into the party board. Okay, so yeah, but just to explain to you like where the things come from. Okay, so this is how we incorporate for the follower. Okay, for the follower, which is this one. So once you know like how to incorporate for the followers, so then you might want to know like the bigger part. So how to actually integrate, like write a program that combine everything together. Okay, so this is one of the questions that a lot of people ask me in the class, especially. So over here, I use this example in we build it like this party board as an example to explain to you how we can put all these things together. Okay, so inside here you can see like the we actually have the speech recognition using the LM to recognize question, and then we have the speech synthesis, which is the robot will use it to answer the question and also to play an audio file. Then we have to take photo, which is the integrate with the visual perception example, which is the first example in the visual class by speech command. Then also we integrate the follower example, the start stop, by using the speech command. Then we also have inside here we have the integration with the move space. Okay, so which means we can control the mobile platform as well, and also the arm. Okay, so basically this program or this example show you all the integration with all the other component or all the other module that we learned before this. Okay, so this is the party board. Okay, so to run this example, so you already have the example, you can run it first and see how does it look like. So to run, you need to run, for example, like you need to run the robot bring up, which is over here we use the Turtlebot bring up, or you can use the Jupyter bring up if you are using the Jupyter, or any bring up, for example, like if you're using the create and so on, then you might use a different bring up for your robots. Then we launch the arm, which is this is the bring up for the arm. Then this one, the follower tool, is the bring up for the follower. So you can see like we bring up all the function before we start our program. Then the last one is we bring up the party board, okay, which is the party board. You can see like this format is very similar when we run our speech recognition example, which is the LM, right? If you remember, like when we do our speech recognition, we run the LM mode, which is we run a launch file, and then we have we need to specify the dictionary file and the LM file, which is over here. We use we already like generate a party board dictionary and LM. So we run this, and then we have everything run for the party board. Okay, so I want you to see the example before I show you the coding. Okay, so in order to show you this example, and also like please pay attention to like the demonstration, how the recognition, content, the synthesis, how to take the photo, how to do the follower, and also the move, to move the robot base and also to move the arm, I would like to invite uh, our friend from Jupiter Robot to show you the demonstration of the real robot. Okay, then after you see all this example, then I will explain to you how I actually do the programming. Okay, okay, so I would like to pass the time to Jupiter Robot. So David, are you there?
Hi, Jeffrey. I'm here.
Okay, so I will pass the display to you. So
Okay,
please
thank you.
show the example one by one to see all the functionality.
Wait a minute. I need to send the sound to the meeting room.
Okay, right.
Okay, now we are ready to show you the demo of Party Boy. You can see the robot is ready at the center of the room, and the right corner, left corner is a screen of the robot. So I will show you how to run the program on the launch file to run this demo. First, we need to bring up the robot. So we have shown you before we use our own launch file to launch our Jupiter robot. So we launch Jupiter robot bring up, Jupiter robot bring up to launch the robot. Can you hear the sound to indicate that the robot is ready? And then next is launch bring up of the arm. As in home, arm down, arm down launch. So pay attention to the display of the telemeter. So if there is a right information, which means that is something wrong with the motor file. So we need to restart the arm launch again. Okay, you can see there is indicated that 1, 2, 3, 4, 5 is ready. Okay, the next is follower. Rose launch. Say home. We use Oh, push up. Sorry. Follower 2. Follower 2. And the robot is waiting for the command to start the follower. Now, you can see the robot is follow the operator. And the next is main launch, Rose launch, RC home, PP's, sorry, Party boy don't launch. And we need to specify the dict and LM file. So the first is the dict. We need to find out the dict file position. I mean the name of the folder. It's here. Typing src as a home apps party boy config. Okay, we have all the config files here, and we can use Control plus L to get the file folder name, copy, and right click paste, and the name of the dict file, properties, copy, host, and then the LM file name. So we still need the photo name, host, and the dict file name. Okay, ready to go. Uh-oh. Let me restart the program again. Let me check where. Okay, please pay attention to the sound. Can you hear the sound, Jeffrey?
It's not clear.
Yes, it's not clear, but the camera is a little far away from the robot, so the operator will speak loudly. Now the robot is start follower, and then the operator can see the command to stop the follow. The operator side stop follow, the robot just stop follow. Okay, you can see the robot stopped here and did not follow the operator. Next, the operator side introduce yourself. You can see in the command window, the program show you the result of the recognized result. It's not very clear. Let me show you, make a little difference here. Once again, introduce yourself once again.
I heard you want me to introduce myself. I am Partobot. I am a party robot to serve you and have fun.
You can hear 2 times of the sound because the reason is one from the camera, one from the microphone from the camera, and another one is from the computer in the robot. Okay, next.
I heard you ask about my age. I am 5 years old.
What can you do?
I heard you ask me, what can I do? I am a home robot. I am good at singing and dancing. I tell funny jokes, and I take great photos of people.
Sing and dance.
You want me to sing and dance? Sure, let me show you.
You can see the robot moved and with the sound music, and the arm is show some actions. Tell a funny joke.
You want to hear a joke? What is orange and sounds like a parrot? It is a carrot. Ha ha ha.
Take a photo.
You want to take a photo? Okay, get ready. 1, 2, 3, say cheese.
The operator side follow me. The robot
Okay, I
start to
will
follow
start
again.
follow you.
Okay, stop follow. Can you hear me and see the screen here?
Yes. Okay, I'm taking back. So maybe you can put back your screen.
I think something. I think I have finished the demo.
Okay, right.
And I will show you the photo to where to save the picture. Just take photo, take the picture. So here, you should use Control plus H to show you the hidden photo. Here, point rows, and you can see the picture here, which with time as a photo name, as a picture name. Okay. Okay, that's all. Thank you, Jeffrey. Thank you.
Okay, thank you, David. Right, let's change back to my display. Right. Okay, wait. Do you see mine? Right, can you see my display back here? I hope like everything is okay and you can hear me back. Right, so thanks Jupyter Robot to show us the party board example. So over there, just now a few functions you already like can notice. So like for the first thing is like we integrate the follower, which is we can tell the robot start follow me or stop follow. Then by speech command, then the follower will stop and start accordingly. So that's the first thing. So we integrate the follower program, which is we don't rewrite the follower program. We just use the start stop to integrate. Then we have the speech recognition and also synthesis by using the LM, so that the robot can hear the question from the user. For example, like we talk about like introduce yourself, sing and dance, and also the rest, like for example, like take photo and so on. Then with that, the robot can respond verbally by using the speech synthesis to tell like, okay, you want me to take a photo, like 1, 2, 3, cheese, so on. Then it also integrate with the take photo program, right? And also the last one is this to move like sing and dance. So you can see the robot actually move itself, which is the mobile brain moves itself, and also the arm actually moving with a certain dance sequence, and also the song playing in background so that you can have something like a dance move. So those are the things that shown just now in the example. So the next thing I will spend like sometimes to explain to you how all these things being integrated together in the program. Okay, so let me go back to my yes, correct. So this one. So if you go back to the example code, in this APPS. So you can find a folder. So this one you can find if you already installed our VirtualBox. You can find this thing under RC Home Edu LearnROS, which is this folder is under your Catkin workspace. So you can find this folder. From this folder, you can see it's actually very simple. It's just like your normal folder after you have create using the Catkin package, right? So after you create, over here, just a few, like for example, the sound here is basically just the sound file that we prepare. So this one is the sound file that you can prepare over here for the sound module to play the file. So nothing special for this one. So we prepare the sound file. Then also we have a config file. So this one is the folder or all the files that generated when we compile our speech database. If you still remember in our class in for speech interaction, particularly the LM mode for speech recognition. So after you create the database or the corpus file, you can upload to the CMU website in order to compile and obtain your LM and dictionary file, right? So after you download the folder, the file, and then you unzip it and put it under this, which is you want to use it. So we just unzip and all the file over here. But inside here, we only use the dictionary and LM. But if you open up the corpus, you can see these are just a few that we need to interact with robot. For example, like follow me, stop follow, take a photo, sing and dance, tell a funny joke, what can you do, where are you from, how are you, or introduce yourself. You can see like just a few very simple ones because these are all the things that we design for the Q&A, right? For the Q&A. So these are all our design. So we send this corpus file to the CMU site to compile, and these are all the files that we obtain. Then we will use this LM file and this dictionary file, these two files, to use for our LM speech recognition. Okay. Then other than these two, we have the launch and script, which is as usual. You will write it for your application. Okay. But for launch, maybe you just copy this launch from this one. You just copy from your speech launch file because it is actually very similar. If you look from this file, I actually copy from, okay, I copy from here, okay, just to show you how, where I built this thing. So if you go to the speech, so I use the speech example as the base for my application. So if you go here, so the same, this RoboCup folder is similar like the config folder in the party board, where you have all the speech recognition related library file, which is the DIC, the LM, and so on. And then you can see like the launch file. Okay, you can see this LM launch file is actually the same. Okay, the same as this party board launch file. Okay, so I just use this. But of course, like down here, I need to add a few more launch nodes. This one is because when I launch the sound, for example, I need to launch the sound play node, which is I don't want to run the sound separately, so I can write the note here. And then for the arm, I need to run the arm and then take photo and so on. So I just write all this related node that I require for my application. So I just combine all the node available in all the launch file together in one big launch file. Okay, so this is how I put those things together. So you can see inside here, we have the sound play, and then the arm, which is the arm BY, and then we also have the take photo sub. Okay, this take photo sub is exactly the same example that we show during the visual perception class, okay, to show you how to take the photo. So once we launch this, we have the take photo sub. So all you need is just to send a message to the take photo sub topic, and then you will start to take the photo. So that is how you integrate. Then lastly, of course, we have the partyboard.py. And okay, so now let's head to the partyboard.py and see how we write the file. Okay, so it's inside the script. and we only have one, which is this partybot.py. Right. So if you open up this partybot.py, you can see it is actually very similar or based from the example in this speech, which is we have what we call the talkback. Okay, I use talkback as the basic because like our application is voice centered. So which means everything happens when we have conversation. So when the user asks something, then the robot will answer and then will do something. Then another question, then the robot will answer and do something. Okay, so that is how I do use this as our base. But of course, you can use the navigation the navigation Python code as your base or other as your base. It doesn't matter because for convenient, I use this one. So if you look at the talkback, it has something very similar, which is this one give you a framework for the Q&A. So you can see over here, the talkback is like when it's just subscribed to this thing, and then when it receives something in the talkback, then it will answer. So it is similar like in your LM. When you hear something, then you need to do something. Okay, so that one is inside. If you oops, sorry. Okay, so if you look at the partybot, okay, over here I write things in class. Okay, but you can remove this class if you don't want. Then you don't need all this self. You just use write as normal. Okay, so over here you can see like I subscribe to the LM, which is I have a talkback over here. Can you see this talkback? And my main program is actually inside this talkback. Can you see that? Right? Okay, so in this talkback, which means every time when the robot hears something, okay, it will try to compare with our very simple logic in order to compare whether is the user try to ask something. Okay, try to ask, for example, like for example, introduce yourself. Then you will have this, for example, here. I hear you want me to introduce myself. So I'm partybot. Okay. So for this introduce yourself, the robot just need to say something. So it just reply with a say. Okay. But for other thing, for example, like follow me, it reply, okay, I will start follow you, and then it turn on the control follow, right? So this is where you connect between your main file with other function. So now I have this as the main, and then I have the follower, which is running parallel, and I use this control follow to actually do the control. And from here, I connect this with my speech. So basically, this is the whole architecture, okay? So you just need to slowly like look back this file or this Python code, and eventually you can find a general framework that is very simple. It's just like, okay, so the first is like I combine all the library that I need. Then I start to define all the node and also my subscriber and publisher. Over here, I subscribe a lot of things. For example, like I subscribe this LM thing. Sorry, I only subscribe to this LM, but I publish a lot of things. I publish to the dance arm, I publish to the take photo, I publish to the base, and so on. So this publish is actually for you to control, to give command. For example, for the camera to take the photo, for the arm to do the dance sequence, for the bass to move, and so on. So this is how I connect with another package or another module, right? Then down there, I just use this talkback for my Q&A, which is when I have a question, and this question is introduce myself, then my answer is, okay, I hear you, then what I need to do. If you ask me how old am I, then I need to answer like what is my age. Then if you ask me to follow me, okay, then I will say, okay, I will follow you, then I will start the follower, right? And so on, and then stop, then this is how you stop it. And then, for example, a more complicated one, for example, like if you ask me to sing and dance, which is I need to move the bass and also to move the arm, then this is how I move the bass, right? And also, I move the arm, which is I send, I publish a dance arm to move the arm and so on. Okay. So this is how I integrate everything together, and that's all. So I hope by looking at this example, you have some idea how you want to put all these things together. So if you're not too sure, please look back at this so that you can have a reference how I do the party board example. Okay, so with that, I have finished my first half, which is, yeah, I used quite a lot of time for my first half, but doesn't matter because this is the most important part, okay? Right, so for the exercise, all you need to do, okay, so let's look at the exercise. So for the exercise for the first half, what you need to do is, okay, let's look at this. You learn this robot system integration by updating the party board example that I just showed you. Okay, so what you need to do is, for example, you can modify the speech interaction content to suit your robot design. So you can change the question and you can change the answer, right? It depends on what kind of, but not forgetting, you need to update the database, which is you need to write the new corpus. You need to recompile to get your dictionary and also LM file from the CMU website. Then you need to link it with your LM program, right? Then yeah, so this is how you can redesign. You can use the same framework or same example, and then you update the Q&A, or you can add more Q&A. Okay, so it's up to you. Then you can improve the robot vision-based interaction by using face, people recognition. So over here, I integrate with the take photo. You can try to think of how you want to integrate, for example, with the face detection. Like you can ask the robot, how many people in front of me? Then you can run the face detection. Then from there, you get the answer from the face detection program, and then you reply, okay, I saw 5%, I saw 3%, and so on. Right, you can improve with this. Then also you can add a map, because this party board, I make it into an example that I can run it anywhere. So I cannot have a map of anywhere with the robot, so I don't actually include a map. But you can include a map and you can put in the navigation example so that you can tell the robot, please go to kitchen, then the robot will go to kitchen. Please go to whatever place that you already define in your map, then the robot can move to the particular place. So you can create this, improve this example until you are familiar with this party board example. Okay, so I hope you get the whole idea. Right, okay, so with that, I finished the first half. So let me go to the second half.